Well, I'm here now with Bill Gaede. He is an Argentinian-born physicist and also a thinker who has many innovative ideas about what physics is, about what physics should be. He's also an artist. I think he plays the guitar, but we focus here on physics. And he pretty much thinks, I don't know if he would agree with this terminology, but from what I gather, he pretty much thinks all modern physics, mathematical physics specifically, is fictional. Is you use black magic and math magic. So please fill us in, Bill, about how is this fiction and how do you feel about it and think about all this?
Well, in order to start, I think we need to have some definitions. If you look at, for example, what fiction is or what fantasy is, it's still within the realm of imagination. You can still imagine it. Let's just give an example. Little Red Riding Hood, Alice in Wonderland, Snow White, right? It's fiction, it's a cartoon, right?
Yeah.
But we can all imagine what's happening there. Even the wolf eating, grandma or attacking and talking and attacking Little Red Riding Hood. We can all imagine that. Okay.
Yeah.
What's the difference with that and mathematical physics? Mathematical physics is not fiction or fantasy because it's unimaginable. You cannot imagine it. And you say, well, why can't you imagine mathematical physics? What's different? What's different is that they're in the movement of concepts. And let me give you an example here, okay? Let's give you an example. There's a saying in English, relatively famous, love moves mountains, right?
Yeah.
It's poetry. And it kind of condenses the notion that if we all have love, if we love one another, we can do lots of big things. So they say love moves mountains. Okay. Now what happens? Now you go to a physicist, a mathematical physicist, and you say, hey, this mountain of sand or whatever moved from A to B. How did it move from A to B? And the mathematician who calls himself physicist, he says, love moves mountains. And you say, hold it, you're saying that love moved the mountain? Yeah, see, this grain was moved by love, this one was, and he explains this whole theory. And you say, hold it, but are you saying that you have this concept called love and you moved all these grains of sand from A to B? Well, you're taking the analogy too literally. You're not supposed to take it literally. So we have a contradiction because he explained for 2 hours how love and any bit of it moved one grain of sand at a time from A to B. And at the end of the story, when you say, well, that doesn't make sense, he said, but you're not supposed to take it literally. It's just an analogy. Analogy for what? I need to explain how the mountain moved from A to B, and you're telling me it was love. And when I question you, you say that I'm taking the analogy too literally. That's what's happening right here. You cannot imagine a concept such as love moving grains of sand. And that's more or less what we have. If you look at general relativity, right, Einstein's general relativity, what do they say? Well, they say, what is gravity? Well, gravity is the warping of space, time, right? We're warping space and we're warping time. What is time? Time is a number line. It's not a dimension. It's not a coordinate. It's not a vector. It's a number line. Mathematicians only work with number lines. And so you ask them the question, why doesn't the Earth that goes around the sun, why does it fly out of the solar system? And he says, because space-time is warped. And they show you a picture. They show a canvas. There's a depression in the canvas. It creates this funnel. The Earth is rolling around the funnel, and that's why it can't go out. We all understand what they're showing. And you say, okay, so you're saying, let's see if I got you right. You're saying that we're warping space-time, which is a concept, number lines, right? And that's what prevents the Earth physically from flying out of the solar system. You're taking the analogy too literally. You're not supposed to, it's just an analogy. So we have a problem because I have to explain why the Earth doesn't fly out of the solar system. The person says, the relativist says, it's warp time. And when you question that, it says, hey, you're not supposed to take that literally. So what have we understood about the mechanism of why the Earth doesn't fly out of the solar system? Again, mathematical physics, unimaginable because they're in the business of moving concepts around. They move fields, they vibrate the field, they transfer the energy, they move the mass, they wave the wave. What is that? We're moving concepts around, and that's unimaginable. Whereas Little Red Riding Hood, Alice in Wonderland, Snow White, they're imaginable. That's why that's fantasy, and this is not even fantasy, not even fiction.
So what you seem to be implying is that in a value scale, let's say, current physics would be sort of even inferior to fiction itself, in a way.
It's irrational. I call it irrational because you cannot even imagine it. If you could imagine it, you could say, okay, it's a theory. I don't like it, but okay, but I can at least visualize it. I can make a movie of it. I cannot make a movie of warping of space-time, which they do. They illustrate a canvas, a trampoline that's being depressed downwards for whatever reason downwards. They illustrate it and they say, don't pay attention to that. If you want to understand it, you got to take math at college level.
Well, I'm going to ask you some questions about your opinions about how this may be used, like maybe in a social engineering. People watch sci-fi movies and they all talk about those black holes, the time travel, warp space. I understand, and we're gonna get to your mechanism, which I'm familiar with for many years now, the rope hypothesis, the torsion. We're gonna get to that because you affirm physics has to be done with objects, and they are doing it with concepts, but they try to mask it somehow. You affirm warp space-time cannot be an object. Graviton particles, well, the particles, we're going to get that. But do you think mainstream physics is a kind of, you also compare it to a kind of religion, like it's based on belief. Do you think this entrains with some kind of social engineering in which Hollywood and all those guys together, they, inculcate those notions on the public because everybody knows there's a black hole and such, and twin paradox? Do you think this is used as some kind of social engineering, and even to prevent people like you and other rebels to propose new revolutionary theories or hypotheses?
Well, the way I look at it, I don't wear a tin cap. The tin cap is saying there that means that you think everything's a conspiracy. So they say, hey, you're wearing a tin cap. Well, I don't wear a tin cap. I don't think there's a program or some kind of directed thing up there to prevent people from coming up. What has happened is the following, as I understand it. I'm just going to give you my way of looking at this. Since the 17th century, where you had Newton, you had Galileo, you had René Descartes, Huygens, and other so-called physicists, mathematicians who wanted to understand how the universe works, they went out there and they said, look, we need two things. We need experiments, which Aristotle did not have, and we need equations. So they developed equations far beyond what the Greeks did, okay? So they began to develop equations and do experiments, observations. Based on that, they developed the equations, okay? So that was the starting point, was known as the scientific method, the revolution, right? Scientific revolution, they call it. Okay, so what happened? We're doing the scientific revolution now for 400 years. Now we're or maybe a little more. We're in the year in the 21st century now. Okay, so fine. What has happened? We've done experiments and we've done observation. We've done equations. But here's an experiment, right? I'm going to let go of the spoon. It's a spoon, right? I'm going to let go of it, and it falls downwards. Okay, so I can do this experiment 1 million times. This doesn't mean that I can explain why this fell. Why? Because I cannot see or touch whatever's in contact with the spoon. I don't know if anything's pushing. I don't know if anything's pulling from the bottom, right? I cannot see or touch it. So there is no experiment I can run to determine what the mediator, the mechanism of gravity is. There's no experiment I can run. We're done with experiments. This is the only experiment we ever needed. Spoon falls to the floor. Okay, now we have to explain it, period. And so these people are still using the scientific method that was created in the 17th century, which is experiment, observation, prediction, and equation. And the problem with that is none of that serves to answer the question we want to answer, which is what causes gravity? Why do things fall downwards towards the center of the earth? So we have a problem because the method doesn't help. And all these people, they just followed this for 400 years, from one generation to the other, teaching the same thing to the next generation. And this is what they're born with. This is what they study at the university. And this is what they repeat. And so the problem is we have the wrong people trying to answer the question of what causes gravity, what is light, how does an atom work, why does a magnet attract another? Here we have two little magnets, and you can see it attracts them. We say, how does it do it? Well, what's the magic? And all we need to answer is, this is a simple thing. This is the whole universe for magnetism here, right? And these people are the wrong people to answer the question. And what's the problem? Because for 400 years, they've been doing the same thing over and over again. Experiment, equation, experiment, equation. That's what they expect. If you want to answer the question of what is gravity, you have to go to college. You got to go to the university. There you get brainwashed to repeat the same thing we've been doing for 400 years, which is experiment, observation, equations, and predictions. And so they haven't gotten out of that. It's not that there's a conspiracy. It's that's what they do. Those are the people who are in charge of physics, and we all have to live with that because it's like I say, it's like in the 4th century. In the 4th century, you had the monks, and they were the only ones who could read, the priests and the monks. And so here were the people, the agricultural, the farmers. They didn't know how to read or write. They went to church, and here was the only person in the town who could read and write. And he would say, oh, this is what God says. This is what the Bible says. And they had to believe it because they had no other choice. They didn't know what was going on. They had to believe the priest. And today the priests are the mathematicians. We all go to the mathematician. The mathematician tells you, look, this is what we proved. Here's the equation. We know it all. And people say, well, I don't understand anything about math, so you have to accept it. And so it's not that there's a conspiracy. That's the way things are because that's the way things developed. Okay. And then anyone who doesn't follow that is excluded and becomes an independent researcher like me.
Well,
so there's no conspiracy, no tin cap. Okay.
I understand your point of view, and I agree. You don't have to say to believe it's a conspiracy, but it's pretty much you say people are brainwashed into the kind of a cult mentality. Would you agree? Do you think maybe? Yeah, go on.
There is a cult mentality, yeah, because people just take it for granted that that's the way things are, and all these researchers, they can't all be wrong, and everybody across the planet does the same thing. So it's a kind of cult, yes, an elitist cult, because it's just the mathematicians who rule that world, right? And they all understand each other, but they don't communicate to the public what they're supposed to communicate, which is what the public is asking. How does gravity work? How does magnetism work? They're not answering those questions. They say, here's the equation. That's a description. I want an explanation. They can't give you an explanation. And so here we are. This is the situation. But what's the issue? This is a special type of cult. When you have a religion, such as traditional religions, Christianity, Orthodoxy, Buddhism, Hinduism, whatever, again, all of that is imaginable. I can imagine God. If they say, take Christianity, Christianity is God. Well, you look at the Bible, it says he's a guy with a beard. He looks like us. He made us in his image. We can all understand that. I don't care how you draw God. Michelangelo has his God over there at the Sistine Chapel. Okay, so you take that God and say, okay, that's God. Fine. I can understand because I can see God there. I cannot understand space-time because when I look at space-time, I see a bunch of number lines that are bent. And that doesn't make any sense. It's irrational completely, trying to give a physical interpretation to the mathematics behind space-time, behind Einstein's field equations. So one thing is the mathematics, that's fine. They can measure and do whatever they want there, but don't bring it into physics because you cannot translate your equations into physics. That's where the problem is. And these people are saying, we are physicists. We are mathematical physicists. Mathematical, maybe. Physicists, no way, because they cannot translate their mathematics into language, into images. Whatever they put out there as images, whether it's space-time, energy, fields, waves, all that is nonsense because what they're doing is trying to make an image of an equation, of a number, of a variable. That's what they're trying to do. And you can't do that. Physics is physics, math is math. Never the twain shall meet. Never can you merge them. So there's no such thing as mathematical physics. It's mathematics or physics. You can't have both.
Well, would you say also it's irrational? You just stated, explain why.
Yeah,
do you think, and if we go to the Copenhagen interpretation, for example, and we know the conferences there were many debates. Some of the guys didn't want to accept because they thought it was irrational. They say, well, we can't know what reality is. It's quantum. It's a wave of probability. Niels Bohr championed this interpretation. It's a wave of probability which is indeterminate. It's a mess. So what do you think the public, the general public, what do you think this has an impact on if it's irrational? And it says something like the Copenhagen interpretation, which I'll add up later, so as we save time. I will explain later in the video. Do you think this has an impact on the general mentality? If it's irrational and it's based on things that are, spooky and stuff, do you think this makes society in general less smart, more irrational, worse in any way? Or do you think it's just irrelevant? It's relevant more for the physics area, or do you think it leads in?
I think it's worse than that. I'm sorry, but I'm going to give you my opinion here. I think it's worse than that. I think it's apathy. People have lost interest in physics and science, in explanations, not the technology. The technology, people confuse technology with science and say, oh, look at all the technology we have. We have all these smartphones and we have all this, we send rockets to the moon and whatever. So people think that, oh, the scientists must be doing all right because look at all the technology we have. It's like if technology were a way of confirming the theories. So they say, look, if quantum were wrong, if it were irrational, if it were whatever you say, then we would not have computers. If GPS were wrong, we wouldn't. If relativity were wrong, we wouldn't have GPS. That's their way of thinking, and it's really that. Are we going to say that because computers work, it proves quantum, which says that a particle can be at two places at the same time? Does the fact that GPS works means that time is something you can stretch and you can drag around the Earth, as proven supposedly by NASA's Gravity Probe B? So we have a problem with the physical interpretation that they're giving us. And I think what has happened, people have lost total interest. There's apathy. And so it's not like people say, oh, we're dumber now. It's like people don't care. That's on the side of the public. On the side of the mathematicians, it's much simpler than that. They say, that's philosophy. They don't say, they say, it's not physics. Oh, you're talking about metaphysics. You're talking about philosophy. We don't care about that. We don't do that. We do math. We do equations. We understand it under equations, not under physical interpretation, because that's opinion. That's philosophy. That's what's happening. So there's total apathy from the public.
Yeah, I agree. But at the same time, they put on all this, light show about the black holes, and I'm not saying I'm here. I'm an agnostic here about all this. I'm not a physicist. I respect very much your hypothesis, but I'm not advocating for one or another. I'm giving you the space to tell your hypothesis. I'm not saying that there are or there aren't those concepts or things, but they put on very much light show, a lot of movies and explanatory videos, and people, if you go on the street, people, yeah, there's black holes, there's wormholes, there's time travel, and some people, you talk. I'm seeing your video about consciousness. There is the consciousness into physics, so the mind collapses the wave function, and the cat is dead and alive at the same time. I know Schrödinger actually made it so as to prove to tell how absurd that was, but somehow people get the wrong impression. Quantum physics tells people that reality. Richard Feynman said reality, we can't understand it. It's irrational. Niels Bohr said there is an irreducible substrata which we can. It's reality is irrational. Don't you think maybe this causes
what's irrational is the explanation. And let me just say something else about that. People, the common man out there, he doesn't care too much about all this sophisticated stuff. He doesn't understand it all because the mathematicians are telling them in their faces, we don't understand it either. You have Richard Feynman saying we don't understand it. We don't understand quantum mechanics. So, but this is the issue is that people out there, they say they like fantasy, and there's one fantasy that they can more or less illustrate. They say, look, there's a black hole. Okay, what's a black hole? Well, it sucks everything in the universe, turns stars around. And so people more or less have an intuitive notion of what the mathematicians are saying, and they like the fantasy. They say, oh, look, what happens if I fall into a black hole? Well, I can end up through a wormhole in another universe. Oh, that's fun. That's great. I love that. It's just the thought that they get. They don't care if it's real or not, but they like the fact that they can dream about it. They can visualize something fancy. And so they don't have their feet on the ground when they're thinking about that, but they don't care. They like the fantasy, the fiction of it, the fact that they can dream about it falling into a black hole, being stretched, spaghettification as they call it, and end up in another universe because they weren't destroyed by the singularity, et cetera, et cetera, et cetera. And so part of the problem is that people want to believe in fantasy, and that's why to a great degree, a lot of this stuff has had success in mathematical physics, putting that into the public, because the public first doesn't care about reality, and second, they like the fantasy of that. Hollywood loves to make movies about that kind of stuff, like, oh, you fell into a black hole, this is what could happen. And this is a documentary because this comes out of mathematical physics, this comes out of Cambridge and Harvard. So it's like Interstellar. That we live in. Yeah, this is what we ended up with.
Yeah, and I don't know if you've seen Interstellar, but I'm not going to spoil the movie, but pretty much it has to do about love. The fifth dimension and the black hole is related to love, like you said. It's ironic. You called it, but well, we can agree. Science, the new what used to be the priesthood is now current mainstream science. That's a fact.
Yeah, Alice in Wonderland has become real now. You can fall not into a rabbit hole, you fall into a black hole.
Yeah.
Forever.
But
never reach the singularity.
But we have now a model which is repeated: trust the science. Like you trust in, like people today, people yesterday trusted the priesthood. Would you say that is correct?
The what? The Brit?
We have the saying often repeated: trust the science. Trust the science. Just turn off your mind and trust the science, like a priesthood.
In the old days, they called it faith.
What?
I mean, traditional religion says you don't have to rationalize.
Faith,
you have to believe by faith. This is the same thing. We're in the same boat as we were 1,000 years ago. We're believing through faith. We're having confidence in the priests that translate the math into what they claim is the reality.
Yeah.
They translate it. We have to believe it because we don't know the math, and we say, "Oh, I don't know all that, all those equations, all that linear algebra, all that calculus." So I'll let the experts tell me what to believe. So in a sense, the mathematicians are putting their peace of mind in your head and say, "You have to believe like me because I'm smarter than you." That's essentially what it comes down to.
And I don't want to get sidetracked, but people say mainstream stuff is often like this about economics. I know you also had interest in this topic.
What was
that? Mainstream sciences, even human sciences, they tend to have this like using in a loose sense an esoteric and an exoteric. One version for the experts and one version for the public. So when Brian Greene, Brian Greene, when he comes out, he says, take this sandwich, this big piece of bread. This is space-time. And now I'm going to cut it, this is for the public.
Slice it up.
Between themselves, they know they know that they don't know. We're lost. But we have to present a kind of fantasy, a kind of light show for the people. And it seems like it's like that. Between them, there is crossover. Sometimes they admit, well, we don't know. This is a representation. But what stands out, what leaves the impression is that all those pictures they present or movies are objectively real, and the people swallow it. That the trust them. But deep in their innermost circles, they don't know what the object they are talking about, the substance, like you said. They don't know what it is they're dealing with. So basically, it's just not numbers.
What they're trying to do is because you have the what is called the scientific papers, which is just equations. You won't find a single picture. I mean, you go to the literature, what they call the scientific literature. You won't find a single picture. There are no pictures. All you see are equations. You see maybe a graph. Maybe you see a table of numbers, etc., values. You will never find a picture. So there are no pictures in mathematical physics, and none of the magazines or specialized, magazines. But someone has to translate that to the public, because the public say, hey, we're paying these guys through taxes and through schools, etc. We're paying these guys to do all this research. What's all this research for? Well, let me tell you why. And so they have to have a translator from the math to the images that the public can more or less relate to. And so they say, well, this is what the math tells us. And so they say, look, space-time, we have a canvas. The atom, we have this little ball and a little electron going around it. So they have these images, and they try to explain the best they can with those images. But then you say, but why does the electron fly away? Why does it fall to the center of the nucleus? How do you bend space-time? You have a lot of questions. People say, and the mathematicians say, well, don't take it literally. It's just an analogy. It's what our equations tell us, that we cannot put our equations into words, into images, but this is the best we can do so that you can get an idea more or less what's going through our minds in our mathematical world. If you really, really want to understand it, you really have to go to college, take the university math, and then you'll understand what we're saying. But the best we can do is give you these images, and we don't understand it either, but that's philosophy. So don't worry about it. That's not what we do. But we have to present it to you in some way.
How come, if it is irrational, I don't know if you postulate that the universe is rational, but if their science is irrational, how come they manage to succeed in making predictions and technology and stuff like that?
Well, the first thing, we have to separate technology from the explanations. From mathematical physics, the explanations are totally irrational. They're irrational because they move concepts around. So that has no bearing on physics. The other issue is that they have answers for everything. They found answers over time for everything. So they say, look, Father Universe doesn't think like humans do. So we are petty humans with these little ants who are trying to understand how God works out there. You know, Father Universe, he runs his shop. We don't understand it, but he doesn't have to communicate to us or with us. Well, all we can do is try to interpret as best as we can what he's doing, but his mind is different than ours. What he does is different than ours. So with that, they neutralize any questions. If you say, but you don't understand it and I don't understand it. Yeah, we don't understand it because we don't understand the ways of Father Universe. He runs the universe this way. And from our little tiny little brains, all we can do is try to figure out how he's doing this. And this is the best we can do. And we're still researching. So if we don't have an answer to a question, it's because we're still researching it. And so with that, they just keep you, you know, with a carrot in front of you, paying taxes, you know, because you got that carrot and say, oh, I'm going to reach the carrot, you know, and they always keep you going. I mean, if you look at quantum mechanics, for example, right, it should be very simple from a philosophical or a conceptual point of view. There should be an ultimate particle that makes up everything, because that's what quantum is about. Saying, look, if it's a particle, there should be an ultimate particle that makes up everything. The muon, the pion, the electron, the proton, all of them, right? And what do they say? They say, well, here's the pion. Okay, what is it made of? Well, give me more money. I'll build a bigger collider. I'll smash 2 pions or 2 muons or whatever. I'll break them up and I'll tell you what I'm made of. Okay, so you give them more money. They make their collider. You collide 2 particles, 2 muons or whatever, and they say, okay, what is it made out of? It's made of 2 charties. Okay, so what is a chartie made of? Well, give me more money. I'll make a bigger collider, smash them at higher speed, and I'll tell you what the chartie is made of. And when you do that, they say it's made out of Johnny's or Charlie or Pete's.
But that's about
and this is a conceptual. This is not an issue of running experiments. This is a conceptual issue. You should be able to go in there and say conceptually there should be an ultimate particle that is indivisible that makes up everything else. And that's not what they do. They say an electron is an elementary particle. Okay, what's an elementary or fundamental particle? It's one that is not made of anything smaller. Great, we're done, right? So the electron should make up everything else. And they say, no, they say it's an elementary particle because so far we don't have the technology to break it apart and tell you what it's made of. Give us more money and maybe we'll be able to do it. So it's never ending.
In the field of explanation, in the field of explanations, you're correct. They don't give precise explanations. They don't give rational working. But how come their mathematical concepts correlate in a way that allows them to make coherent, not only predictions, but technology? Okay, you separate technology, physics, but they use their conceptual apparatus to make workable mechanisms, which is based on their concept. How come there is a correlation between their concepts that are irrational and the workings of the things they manipulate with, the technology or satellites and whatever?
Well, let me tell you, I worked in engineering many years, okay? And in engineering, it's technology related. It's not scientific related. You don't care about the explanation. You care about, getting a product out. So you're looking at technology. What happens? You take a measurement. Because you before you have the equation, you have to have the measurement. The equation comes as a result of the measurement. Once you measure, you play around with the variables and constants and numbers, etc., and you come up with your equation, okay? So first you have to have the measurement, and then it becomes a tautology, because you create a unit, right? You measure, you say the meter, for example, you measure, okay, you say this is a meter. And now it turns out that the table measures 1 meter. Why? Because it's a tautology, because you already made the standard for the meter. So now you have a standard. And so, mathematics in that sense, all equations are tautologies. Whatever's on the left-hand side of the equal sign had better equal whatever's on the other side of the equal sign. Okay, they have to match. Okay, but it's not a definition, it's a tautology. It's the same value in different numbers and variables on the other side.
But
That's what
they have to match some phenomena. They have to match some phenomena.
They have to match because, again, it's a tautology, meaning one side has better equal the other side. 1 + 1 must have better equal 2 on the other side. Okay?
But what I mean is they also have to match phenomena that are really occurring in order for them to make their stuff work, their predictions, their satellites and stuff.
But the point here is that you do not have to know the mechanism. For example, you find out that this magnet attracts that one, right? Okay, so here we have 2 little magnets there, round ones. I think you see them. Okay, so I say, hey, that's magic. I don't know how it happens, but I can use this for something. So you measure and you say, how fast does one magnet attract another? So you measure that and you create your standards and you come up with a value. You say, okay, now I can predict. I can use that to do something in the future. Okay. So now you make these bigger magnets and you say, hey, I can use that for something. I can put a big magnet and lift a car at the junkyard. Okay. So you go in there, you create this big magnet, it lifts the car, and you say, I know how fast it's going to do it. I know how much time it's going to take. I know how much energy it's going to take because I measured all that in advance. So I can already plan, program, predict in advance what's going to happen because I've already measured it. None of that tells me what is a magnetic field. None of it tells me how a magnetic field works. Well, what's that invisible stuff between two magnets? That's the problem.
They succeed because they are correlating information, making associations, but they don't go to the deep explanation. Would you say your explanation is qualitative? The object? Sometimes people get things mixed up. The objective physical explanation is qualitative because sometimes people associate qualitative with subjective. No, the qualitative, it has to have a shape, a visualization, a working mechanism. It has to know how one mechanism, one object touches another, and that's real physics. What they're doing is correlation.
Part of the problem comes with Aristotle. He defined the word physics, he defined the word metaphysics, and he put a lot of this stuff into metaphysics, which is sort of same philosophy, like this is what comes after physics. After we do the observation and we have our ideas of how this works and you have your definitions, then you have the metaphysics like, okay, now let's drink a beer and let's think about this and let's philosophize about it. Let's find out how this might be happening. And so they consider the physical interpretations, the qualitative, aspect of it. They consider that philosophy. They only consider the quantitative part of science. Why? Because they can measure, they can predict, and they can say, look, this I understand because it's objective. Whereas the other stuff is subjective. So we'll call that philosophy, metaphysics, or ontology, or whatever. So we have those separated. And what they've always focused on is just the mathematics aspect of it because it's objective and that's what they call science. But you have to remember that mathematics is just a language. Like Chinese is a language, Greek is a language. Mathematics is just a language of hieroglyphics. These little symbols there, it's just a language. It's a language of only adverbs, quantitative adverbs. If you look at a variable, you look at a number, what is that? What are you staring at? What does it represent? What does that symbol represent? It represents an adverb. It represents how something moves when it's related, with a unit, right? It just tells you how something moves. That's all that a variable is with a unit. A number with a unit, that's all it tells you, how something moves, how something was measured. If you're talking about, for example, length, just an example, what you're talking about is not the distance, but the distance traveled by the end of your tape, your measuring tape. So you unroll the tape, you've already made your standard, you say 1 centimeter, for example, right? So you have 10 centimeters, what did you do? What did you measure? What happened there? Well, what you did was unroll the tip of your measuring tape, 10 steps, 10 centimeters, and you call that 10 centimeters. 10 centimeters is not a fixed amount. It's a traveling amount of the end of your measuring tape. and so on down the line. They're all a language of adverbs. And with that language of adverbs, which is what mathematical physics, the ones dealing with units is, that's all it is. That has very little to do with a qualitative explanation of why, what causes, what's the mechanism. Those two are two separate things. And those are the questions people ask, which people associate with physics. They say, look, I want to know why the pen falls to the floor. I want to know how a magnet attracts another. And these people say, well, here's the equation. But that's only a description. Yeah, I want an explanation. I want a qualitative explanation. They say that's philosophy. And so we never get to the philosophy. Here we are 2,500 years later. We don't know what gravity is. We don't know what magnetism is or electricity or how an atom works. We have no idea of any of that. All we have are descriptions, quantitative adverbs, mathematics.
Well, Bill, I'm going to go a little off the record here. I know that this time issue, it's an unfortunate thing. It happened. So would you be so I don't take, we're going to get to our theory to wrap up then. So I don't take much of your time. Would you consider another day, maybe 1 week from now or something like that, making another small 1 hour recording so we can?
Yeah, no problem, Pedro.
No, so I don't take much because you have to be with your family. We wrap up for now. You expose your theory. I make some light questions. I have time, but I don't want to impose. And if possible, one day we can make another 45 or 1 hour meeting in the future.
Yeah, well, we can do a follow up. In fact, next time maybe we can deal with the rope hypothesis.
Yeah. Would you like to talk a little about the rope hypothesis now, or your choice?
If you give me a second, because maybe I give you one picture that is worth 1,000 words.
Oh, all right.
1 second. Let me get this.
Folks, Bill is going to summarize 1,000 words in one picture.
In one picture. I made this because, sometimes people ask impromptu questions and you're not ready. So I thought I'd do this. Okay. I hope you can see this. This is what we all learn in high school.
Yeah.
That's known as an electromagnetic wave. It's made out of a magnetic field and an electric field. The atom that you see on the, what is it? On the,
this is from my left, so we'll see. Right? We'll see.
I'm upside down here. Okay. Anyways, the atom goes back and forth. It does its quantum jump, and it creates that wave which travels one way outwards. Okay. Yeah. So far, so good. So we all learned this in high school. We say, look, the atom pumps back and forth. The electron goes back and forth. It creates what is known as a quantum jump. It creates this electromagnetic wave, electric field, magnetic field. It goes outwards one way. They call it energy. Okay, so far so good. Okay, now here's the real picture. Okay, we're going to replace that. Let me put it this. We're going to replace and we say what they've been always analyzing is a rope. Okay, so what you're staring at there, that electromagnetic wave has always been a rope. Okay?
A DNA-like rope.
And you can see that it's not going outwards in one direction and going off to nowhere. It's attaching one atom to another atom here. Okay? When the atom pumps back and forth, expands and contracts, it torques the rope, and that explains the speed of light. The reason light is so fast, you take a rope, you can do this at home, no problem. It's simulated at home. You can see everything, by the way, from the rope model, you can see everything. If you torque a rope, right? If you torque a rope, right? The signal is the fastest thing imaginable. If you tie a rope, for example, your grandmother's clothesline, where she hangs her stuff, just make it as tight as possible. Put 2 clothespins, one at one end, one at the other end. You move one clothespin, the other one moves instantaneously. A torsion wave, a 3D torsion wave, is the fastest thing that anyone can imagine. There's nothing faster than that because It goes nowhere. It just torques in situ, and it's already at the other end. The signal is already at the other end. It explains the speed of light. It explains the architecture of light, why it's wavy, structurally wavy, right? It's not an electromagnetic wave or transverse wave. It's a 3D torsion wave, okay? And it explains a lot of things, among them entanglement. Entanglement means what? Means that if you have two particles, this one communicates with this particle at faster than the speed of light. Why? Because if they're at opposite sides of the universe, this is from mathematical physics, I'm not inventing this, okay? If they're opposite sides of the universe, if this one goes clockwise, this one instantly goes counterclockwise. And if you switch them around, they instantly, through space, one side of the universe to the other side of the universe, this one goes counterclockwise, this one now goes clockwise. And so I like to show this, okay? You tell me, okay, what you see. In what direction is the rope turning for you, for your eyes?
You got a little higher. Clockwise for me.
It's clockwise. For me, it's going counterclockwise. Let's turn it around. For me, it's going clockwise now. How is it going for you?
Counterclockwise.
Exactly. That's what they've been measuring for entanglement for who knows how long. We can answer many of these questions with a rope model because there is no action at a distance. For gravity, for entanglement, for the gluon, which holds the atom together, the quarks together, one quark to the other. None of that is action at a distance. Action at a distance is the scientific term for witchcraft. It's an action that happens without a mediator. It's called witchcraft or black magic. It's voodoo.
And some magicians, some mages, they look, magic is real. And some people here in the documentary are going to say that.
Listen to this. When you go to see a magician, there's a magician on stage, right? Maybe he's cutting the lady in half or whatever, right? It's a trick.
Yeah.
You just don't know the trick, how he did it, but you say, hey, that's a trick. You don't think that's real black magic, that it's done by, something out of the world. You say, well, I don't understand how he did it, but we call it magic, but what it is real physics that the guy just tricked you.
Yeah.
Mother Nature's tricking us. She doesn't do black magic.
Yeah.
Okay, Pedro,
we
can go in a little more detail next time, no problem. Let's do that. We'll sketch something.
And you speculate also DNA might be a kind of crystallization of this same shape?
This is DNA. In other words, if you look at collagen and you look at some of the, the hydrocarbons that we have out there, they're all elongated entities, twisted entities. And DNA, I think, got its model from the rope. I think it imitated the model of the rope. It's very likely. I mean, Mother Nature's wise in a certain way,
Well, Bill, to wrap up, I hope we meet next time, but to wrap up, one of the most important aspect, not an aspect, the fundamental from your theory, which is, I had trouble understanding. I thought it was only bundles of atoms that were connected. No, you say every single atom in existence is connected by ropes or threads. I don't remember the correct term. Yeah. Every single atom is connected to every other single, literally, atom in existence. All of them are connected directly to each other, physically, to all of them. Not one of them misses rope connection. Is that correct?
Correct.
I had trouble in the beginning.
There's two things. There's something else that you should add to that, and that is not only are they connected, but gravity goes through atoms. You can stand behind a wall.
Yeah.
And gravity will get you anyways. In other words, let's say you're falling from an airplane, right? You can put a wall. The wall will fall together with you. You can't say, "Oh, I'm protected against gravity. I put a wall in front of them." No, goes right through the atoms of the wall. So not only are they all connected, but they go through the atoms. That's important too to show the model. We have to explain those two things.
And they make up the atoms as well.
Aside from that, yeah, that's why that takes a little longer to explain all that, but we can do that next time.
So there are no parallel universes. There is no. This is all science fiction.
Maybe there's one possibility, just one possibility here, and that is, let us assume every atom in our universe, in our group of matter, let's say all those atoms are connected. Okay, for the sake of argument, there could be another parallel universe out there where all the atoms are connected there and none of those atoms are connected to our universe. Then you would have multi-universe, parallel universe. Other than that, this is it. All atoms are interconnected in what we call our universe.
Well, to sum up, thank you very much, Bill. To sum up, Bill Gaede has a theory, which is a theory which explains gravity, explains light, the architecture, the form of light, explains many phenomena, has relations to possibly biology, we'll talk about even the sexuality, explains a lot of things, is rational, has a dynamic picture, has a mechanism, has a picture, it can be explained to children easily, and well, it might as well be true. It makes a lot of sense. It makes a lot of sense.
True is an opinion. All we can do is enrich our minds and say, well, this is a different view.
Well, it is for me, and it makes a lot of sense. For me, it is rational. It is rational. Bill, thank you very much for your time. Thank you very much. I recommend everyone check out Bill's channels, the books, everything. I think that, maybe the future is the road in the future. Who knows?
We'll find out.
Yeah, we'll find out. Thanks a lot. Thanks a lot.
Sure. Have a good day.
You too.